Okay, let's do a quick review of trig. First of all, the unit circle. In the unit circle, um, it's a circle of radius 1. So it goes through 1, 0, 0, 1, negative 1, 0, 0, negative 1. So in there, if you were to just plot this on a piece of graph paper and figure out the coordinates of points around here, you can, using the grid, you can scale it and you can figure out points all along here. In fact, the ancients, we found clay tablets with all these values of points along the circle listed on these tablets. The x coordinate and the y coordinate all the way around the circle. And that's because they use these triangles. If you make right triangles in here, they can make ratios of these to navigate by the stars, to measure their land, and all that kind of thing. So they use these similar triangles all the way around the circle to do those sorts of things. They were pretty good at that kind of thing. Now, first thing you need to know is you can go around the circle 0 to 360, and you can keep going to 720 and keep increasing the angle. Or in standard position, you can go negatively around there, go negative 30, negative 45, negative 60, this way. So you can keep repeating yourself, keep going around and around the circle, either way. If you're doing degrees, that's one way of measuring angles, but another way that's used a lot in calculus is to measure the angles in radians. Now, what a radian is taking the radius, that length, imagine that little piece of wire there, and bending it around the circle. And if you do that, how far will one radius go? Well, if you can imagine that, it would go to maybe somewhere about here. So this would be an angle of 1 radian. Now, if you look at pi over 3, that's 3.14 divided by 3. That's a little over 1. And that is exactly what these numbers mean. This is how far the radius will fit. Furthermore, if you think about going clear around the circle, that's a circumference, and the circumference is 2 pi r, but if the radius is 1, then the circumference is exactly 2 pi. And so in radians, this is an angle, 360 degrees is 2 pi radians, and 180 degrees is equivalent to pi radians, 3.14 radiuses laid out on the circumference. And so 1 radian is slightly less than pi over 3 because pi over 3 is slightly more than 1. Okay, so if this is pi radians clear to here, if you take pi, or 180, and divide it by 6, you get 30 degrees. And so there's why that's 36 degrees. If you take 180 divided by 4, you get 45. If you take 180 divided by 6, you get 3. So that's a third of the way around the circle. 180 divided by 2 is 90 degrees. So that's the fundamental. And then things on the circle start repeating themselves. For example, if I go at a 30-degree angle, if I go over, and I'll go over some amount in x and some amount y, I get to that place. If I go to 150 degrees, to get there I would go so much in the x and so much in the y, and you'll notice I got the same kind of coordinates for the points, and how we get those I'll show you in just a sec, but they match, and so there's a lot of repetition in the circle. If I go for 45 degrees, it's the same amount of over an x as up in the y. And for 135, we get the same kind of relationship. And also down here, same kind of relationship. And over here, same kind of relationship. And that keeps repeating as you go around the circle. So, now, where do these numbers come from? Well, these are clear. 1, 0, 0, 1, negative 1, 0, and 0, negative 1, because this is a unit circle of 1, 1, 1, and 1. Now, if you take a square, and if you make the diagonal be 1, then these two sides, which is a square, are going to be the same size. And so x squared plus x squared would have to equal 1 squared according to Pythagorean theorem. So that means 2x squared would equal 1. Divide by 2, and x squared equals 1 half. Take the square root of both sides, and you get x equals the square root of 1 over 2, which is square root of 1 is 1 over the square root of 2. If you rationalize the denominator by multiplying by the square root of 2, you get square root of 2 over square root of 2 times square root of 2 is 2. This half a square, this is a 90 degree. If you cut it in half, that's 45. And 45 and 90, and that's exactly what we have here. If we're going up 45 degrees, we've got this side and this side, and a hypotenuse of 1. That's why the x-coordinate and the y-coordinate are 2 over the square root of 2, or 1 over the square root of 2. And you notice that happens here, 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 and here. It's just that they're both positive. Here it's negative in the x, positive in the y. Here it's negative in the x, negative in the y, so they're both negative. And over here, it's positive in the x and negative in the y, and that's why it looks like those. Now these other ones, which relate to a 30-degree angle, if you were to take and draw a equilateral triangle, which means all the sides are equal, and so all the angles are 60, 60, and 60. If you make the side be 1 and 1, and if you split this right in half, this would be 1 half, this would be 1 half. It'd have a 60-degree angle, a 30-degree angle, and if that's 1 and that's a half, the Pythagorean theorem says 1 squared, the hypotenuse is 1 half squared plus something squared. You square half, you get a quarter. If you take a quarter away from 1, you get 3 quarters is x squared. And if you take the square root of both sides, you get the square root of 3 over 2 equals x. So if you look at this 30, 60, 90-degree triangle, just this half of the equilateral triangle, you have the shortest leg is a half, and the longest leg is square root of 3 over 2. Well, if you're going on a 30-degree angle and you're making the right triangle to get to that point, the long leg will be the square root of 3 over 2. The short leg will be a half, hypotenuse 1. And so going over in that direction is the square root of 3 over 2. Going up is the half, and that's 1. If you go to 60 degrees, which is in here, to get there, you go the leg and the leg, and you get that. But now the short leg's here, so the x is a half. The long leg, square root of 3 over 2, and the hypotenuse is still 1. So it comes from these two triangles making a special set of angles. Pi over 6, pi over 4, pi over 3, pi over 2. You go pi over 6, 30 degrees plus 30 degrees, you get 60 degrees, or pi over 6 plus pi over 6 is 2 pi over 6 or pi over 3. If you were to do two 60s, you get 120. That's pi over 3 plus pi over 3. That's 2 pi's over 3. 2 pi over 3's. And you get the same kind of triangle, x and y, except the x is negative and the y is positive. So you get the same numbers with the negative x instead of a positive x. And similar with the signs going around. Okay, so now we know where these numbers come from. And I told you the ancients made tables of these. And it was often called, the x-coordinate was called the cosine of the angle. We'll use theta for the angle. And the y-coordinate was called the sine of the angle. And they used these tables of sine and cosine that they made not only for these special angles, but for all the angles all the way through this first quadrant, because everything repeated in here, other with minus and pluses. All they needed to do was make a table for the first quadrant. In fact, often they just made a table from 0 to 45, and they knew that things repeat coming here where the x and y's are switched over here. So there's so much pattern in here. All you need is the table for the 0 to 45, or 0 to pi over 4. And if you understand the relationships here, you've got all of them. So that's where the sine and cosine come from. And they also made one other table that was often very helpful in navigation, was to know how the two legs relate to each other. They called that the tangent of the angle, which is the opposite over the adjacent. So the tangent would be y over x, or sine over cosine, sine over cosine. So, therefore, we get this list of things from this. The y-coordinate on the unit circle is the tangent of the angle. And t, where t is a point on the unit circle, t is some distance around, so that means they're measuring it in radians as opposed to in angles, but it doesn't matter. T can be an angle in radians or in degrees. You just have to have your calculator in the same mode to get the decimal approximation of these. But the sine is the y-coordinate, the cosine is the x-coordinate, and the tangents, the y divided by x, are sine over cosine. And in this case, you can't let x be 0 because tangent would be undefined. Well, the denominator can't be 0, and that would be the cosine. Cosine is 0 at 90, or pi over 2, and it's 0, the x-coordinate is 0 there, and it's 0 there at pi over 3 pi over 2. And if you continue around, so not pi over 2 or 2 pi over 2, but 3 pi over 2, not 4 pi over 2, but 5 pi over 2, not 6 pi over 2, 7 pi over 2, 8, 9 pi over 2, 11 pi over 2, 13 pi over 2, all of those are going to be undefined for the tangent. That's going to be important when I discuss the graph here in just a sec. Now, they also made tables not only for the y-coordinate, but they made it for 1 over the y-coordinate, and they called it the cosecant. They made a table for the 1 over x theta, which was the secant table, and they made one for the cotangent, which means that it was x over y, the reciprocal of the tangent. That's because they didn't know which part of the triangle they needed to solve for, and so they made a table to be able to solve for any of the 3 sides. And you notice that the cosecant y can't be 0, and the secant, the x can't be 0, and the cotangent, the y can't be 0. That's going to be important when I discuss the graphs in a little bit here. So that's a little bit about the unit circle and what the sine, cosine, tangent, cosecant, secant, and cotangent are. And this is talking about the radians. A radian, if you take the radius, draw it out here, and then wrap it around, you get 1 radian. Or in this case, they went t radians because they went a length of t longer than 1. This is 1, this is longer than 1, so it went around t radians. That's a negative t radians, and this is a positive t radians angle. Okay? So that's the top half of this.